Welcome back, Math 30-1. In this lesson here, we're going to learn how to solve equations involving multiple angles. So to start off, I suggest you try and do this exploration here before you continue with me to the first example. Okay? So now, the first class example says, solving a multiple angle equation using a graphical approach. Now, what we want to do is we want given that tan 2x is equal to root 3, we want to solve between 0 and 2 pi. So first of all here, we have this, we know it's in radians, so I'm going to make sure my mode is in radians. Then my window is between 0 and 2 pi. And now I'm going to graph this. So I'm going to go tan and 2x. And then at the bottom we want square root of 3. And we're going to graph it right there. It's going to look like that. Okay? So what we want to do now is we have two equations, so we're going to find the intersection. So we're going to go second calculate, and I want the intersect. So we're going to first just find this intersect here. I push enter, it's around it, there and there. So my first intersection, and once it's exact, we have x is 3.666. So if I want to get that to exact, I'm going to quit. I'm going to go x divided by pi. And then I'm going to put that into a fraction. So before it's multiplied by pi, it's 7 over 6. So that's the same thing as saying 7 pi over 6 is one answer. Okay? So I'm going to go back here, and we're going to just find a couple more. So let's go here, and I want to calculate my intersection again. Let's find another one. So here's another one. Let's take a look at this one here. And I'm going to push enter, enter, enter. And I get 2.094. So once again, I want to put that in exact terms. So I'm going to get out of there. And I'm going to go x divided by second pi. And go math, fraction. And I get 2 over 3. So we have another one that's 2 pi over 3. Okay? And if I did that a couple more times, I'm going to get pi over 6. And I'm going to get 7. And I'm going to get my last one, because there's 4 of them, is going to be 5 pi over 3. Okay? So those are all of them, because just double check. I have 4, 1, 2, 3, 4 intersections. And these are what my x values are for those intersections. So B says, state the general solution. So I want to know how much these are really going up by. So if I look at this one here goes up by a whole pi. But this one right here, well, what's the difference between this and this? Well, this here is a whole pi as well. But now the difference between these are going to be, so if I go pi over 6 and I go 2 pi over 3, subtract pi over 6, that's going to be the same as 4 pi over 6, subtract pi over 6. So really, in generally here, this is the same as pi over 2. Now, this to that is also going to be the same thing as pi over 2. So really, what's happening here is we're going to say x is equal to pi over 6 plus n pi over 2. Because if I find the difference between this as pi over 2, difference between these is pi over 2, so that's what's happening with my general equation here. So in other words, the general solution consists in the answers differ by pi over 2 radians, which means the period for this function is pi over 2. Now, remember when we did our trigonometric functions? We pretty much here said we replaced x with, x got replaced with 2x. So that means my period got halved. And my period for tan is pi. So pi over 2 is going to be my new period, and that's what we're going up by every time. Okay? So now let's take a look at class example number 2. So for classroom example number 2, we want to solve this equation algebraically. Now, we have some things here to first find. It says first find the domain of the multiple angle. So if I want to find the domain of the multiple angle, if I look at this, we have 2 periods for every one of this. So if I wanted to make it just x, Well, that means I have to multiply both of these by 2, so that's going to be 0 and 4 pi. Okay? Now, that's when we're saying sine 2x to negative 1 over 2. All right? Now, if we're looking at negative 1 over 2, we'll look at this. This is going to mean we're in either this quadrant here or that quadrant there. Okay? So now we're going to just, the reference angle for this is going to be 1 over 2. That's the shortest one. So we're in quadrant 3 or 4, but my reference angle from quadrant 1, when y is the shortest, that's going to be the same as 30 degrees, which is pi over 6. So we know then that 2x is equal to pi over 6. Okay? We're not solving quite for x, we're saying 2x is equal to pi over 6. Okay? Now, I look at this more. I'm going to have here, I have my angle, so we also know that. We have to figure out all the other angles. So we know that 2x is equal to, well, I'm going to have 180 pi plus pi over 6 to get this one. So that's going to be pi plus pi over 6. And then I'm going to have here 2 pi minus pi over 6. Okay? But we also have, if I look at this, we could go all the way around again, which is going to be, we add to this one here 2 pi. So we could go plus, because we have all the way to 4 pi. So if we go all the way once, it's 2 pi, and then plus a pi plus pi over 6 to get back there. So that's going to be 2 pi plus pi plus pi over 6. And then we're also going to have a 2 pi minus, or sorry, plus 2 pi minus pi over 6. Okay, so because we do this twice here, so we go the first. These here are my first two. Okay, so my first one's right there. And then we have to add 2 pi to both of those because it's up to 4 pi. So we go around once and then again. Okay, so when I do this, I end up getting 7 pi over 6 for one answer. This one right here is going to be 11 pi over 6. Then I'm going to end up getting 19 pi. Oops, comma, 19 pi over 6. And my last one's going to be 23 pi over 6. Okay? So this is for 2x. Now I just want to figure out what x is equal to. So all I'm going to do is I must divide all of these by 2. So I end up getting 7 pi over 12. And here's going to be 11 pi over 12. And then I'm going to get 19 pi over 12. And my last one's going to be 23 pi over 12. Okay, so these are going to be all of my angles. Now, it says state the general solution for this. Well, I have two different situations here. I have x is equal to 7 pi over 12. And we have 11 pi. Oops. 7 pi over 12. And we are always adding. My period, remember, is now just going to be n pi plus n pi. And then we're going to have 11 pi over 12. And we're going to add n pi. Okay, because my period is just going to be pi now. Okay? And we have where n is an element of integers. Okay? And if we look at this here, this also falls between our original parts there of what we need between. Oops. And this now follows my original restrictions because 23 pi over 12 is under 2 pi, 19 pi over 12 is under 2 pi, where before when we had it like this number wasn't actually less than 2 pi, that was under 4 pi, but then once we divided everything by 2, we follow within our original restrictions. So B says state the solution to the equation, so we want the general solution now. Well, if I look at this here, we have two situations. I have this situation here, and then I have this situation here. And this is just going to be added pi to that, and this one here is added pi to that. So my solution is we have x is equal to 7 pi over 12. And we're going to be, remember, my period now is only pi, not 2 pi, because of that 2. So it's going to be n pi. And then my next one is going to be 11 pi over 12 plus n pi. Okay? And we want here where n is an element of integers. Okay? And in this case here, we have So now let's take a look at C. It says complete the following statement. The general solution consists of answers which differ by, well, we have pi radians. Okay? Because the period of this is, if I did this, we know period is equal to b, 2 pi over b, and in this case my b value is 2, which is going to give me pi. 2 pi over 2, which gives me pi. Okay? So verify the solution with the graphical approach. So if we wanted, we could just quickly plug this in here. And I'm going to clear. And we had sine 2x is equal to 1/2. So we want negative 1, or 1/2 is 0.5. And we have sine 2. And then here we're going to have x graph. And it looks like that. Okay, and I'm just going to check to see if our first one works. So I'm going to go second calculate, and we want my zeros, or sorry, we want my intersections. So I'm just going to figure out my first one works. Enter. So 2.87. So I'm going to go second quit, and I'm going to go x divided by, and go math, fraction, enter. So 11 over 12, so that is the one that we found out there, which was actually our second one here. Graph, we found out that one, which is the second one, which is 11 over 12. So yeah, I'm going to assume that it works for both. You could check the other one yourself. So for class example number 3, we want to determine the time it takes the Ferris wheel to make one complete rotation. So let's first look at the information here. It says the distance above the ground of a student on a circular Ferris wheel is given by the equation. My height as a function of time is equal to -4 cosine of pi divided by 12 multiplied by the time, all plus 5. Okay? So h is the height above the ground in meters, t is the time to the nearest seconds when the student is at the lowest point of the ride for the first time. So now I want to determine the period first. So one complete rotation is my period. Now if we remember, period is equal to 2 pi divided by b. Okay? Now we know my b value is pi over 12. So period is equal to 2 pi divided by 12, which is the same thing as 2 pi multiplied by 12 divided by pi, which will end up be, that should be a pi, which will end up giving me 24. Okay? So now B wants us to algebraically determine the times during the first minute of the ride when the student is 7 meters above the ground. So pretty much we're solving for this sinusoidal function. So how does that work? Well, first of all, let's go and figure out what is my domain for the angle. Okay, so we want to find my domain. My original domain, if we wanted to go pi over 12t, well, that's going to be between 2 pi and 0. But if we're looking at just t, we're going to have my max is 24 to 0. Okay? So now we want to try and solve this when my height is 7. So I'm going to have 7 is equal to -4 cos, and we have pi over 12t, and we're going to plus 5. Okay? So we're going to subtract 5 from both sides, so I get 2 is equal to -4 cos pi over 12t. Okay? Now divide both of these by negative 4, so I get negative 1 over 2 is equal to cos pi over 12t. Alright, now my next step here is, we know it's cosine. I'm going to use my little grid here to figure out which quadrant we're in. Well, cos is negative, we're going to be here or here. Okay, so I'm either in quadrant 2 or 3. Now, looking at this here, I know this is negative 1/2, so that's also going to be, if I look at my reference angle, when cos is 1/2, that's the shorter cos, which is going to be 60 degrees, longer sine, which is the same thing as pi over 3. So my reference of 12, or pi over 12 times t is equal to pi over 3. So now if I look at this, we're going to have to go here where pi subtract pi over 3 to get that one. So that's going to be pi subtract pi over 3 is 2 pi over 3. And to get this angle here, we're going to add pi over 3 to pi. And that's going to be 4 pi over 3. Okay? Now, I look at this a little bit more. We want to figure out what just t is. We want to know just what my time is. So t is equal to, I'm going to have to get rid of this pi over 12. So I'm going to multiply this by 12 over pi, and multiply this by 12 over pi to cancel it out. Multiply this by 12 over pi to cancel this out. So I'm going to, if I multiply this by 12, that gives me 24. Pi's cancel off. 24 divided by 3 is 8 seconds. And here we're going to have pi's cancel off. 4 times 4 is going to be 16. So now I have my two times. But we have all the way, we want to know the first minute. So we're going to have more than one rotation in a minute, right? So I want to look at my first minute here. So we have to really look between 0 and to 60 seconds. So every time we have a period here, what is going to be my period? We want to always add 24 seconds to each of these to figure out how many more they could go, since my period is actually 24. So my solutions now could be t is equal to, I could have 8, 16, and then 8 plus 24. Then we're going to have 16 plus 24 because we're just adding my periods. Then we could have, let's take a look at this here. We could add 2 periods, so I could have 8 plus 48, and we could have 16 plus 48, and I'm pretty sure that's going to be bigger. So if we continue this here, I have 8 seconds is one answer. I have 16 seconds, and that's going to be 32 seconds. Then we put these together, that's going to give me 40 seconds. And then I go 8 plus 48, that's going to give me 56 seconds. And then I add this, this is going to be over a minute, so that can't work. So my only answers are going to be 8 seconds, 16 seconds, 32 seconds, 40 seconds, and 56 seconds that work. And that's it.